All right. Welcome everybody to Tutor Tuesday. We'll go ahead and get started. I see we have some people who want to cover SAT, ACT, so we'll go over some of those topics. I've got a question. How much progress is possible in 2 months of SAT prep? You could probably raise your score up 100 points or a couple hundred points depending on how much you prep per day and how effectively you prep. Okay. Yeah. Depends on how you study. Yeah, exactly. Okay. So I saw some requests to do some ACT questions, and I also saw requests for Algebra 2 and Geometry. So let's pull some questions from one of the ACT practice tests. You'll notice I kind of left it blank like last time, because I really like that format of you guys telling what topics we want to cover. So let's do our first ACT problem from official test. It should be a pretty simple geometry problem for us to solve. We have a right triangle ABC. Given lengths are in millimeters. What is sine of A? Sine. If we think about sine of an angle is equal to the opposite side over the adjacent side. And if you ever forget that, you can use the mnemonic device SOHCAHTOA. So sine is the opposite side divided by hypotenuse. So if we're looking at angle A, the opposite side is 7, and the hypotenuse is 9, which just makes it D. Yeah, honestly, not too bad. Okay, let's do another little geometry problem. I think the ACT math tends to be slightly more interesting than the SAT. They have questions like this. So in the figure below, A, B, C, D lie on a circle centered at O. Which of the following does not appear in the figure? Well, looks like triangle ABO. If you guys notice, ABO has a angle measure of 60 degrees up by the center. And we also know that this side AO and BO are equal because they are radii of the circle. In that case, if these sides are equal, then we know that these angles are also equal, and therefore we can split the remaining 120 degrees between those two 60-degree angles. So equilateral triangle does appear. Let's rule out B. Here we have a right triangle. We see a right angle, so we can rule out D. Isosceles triangle, acute triangle. Well, now we're just left with, so we can rule out acute triangle, isosceles triangle, and scalene triangle. So acute triangle is where all of the angles are less than 90 degrees. So they're all acute angles. There is, like, this equilateral triangle is considered an acute triangle. So we could rule out A. Then we're between C and E, right? So it's either isosceles triangle and scalene triangle. Well, here we actually have a right isosceles triangle because this side and this side, again, are both radii, and so they're equal. So we have an isosceles triangle where two of the sides are equal to each other. So the only thing that is missing is a scalene triangle, which would be E. Exactly. I like the looks of this question, this next one. It's kind of like a mix of algebra and some, I guess you could consider as coordinate geometry. But it's asking for the slope of a line that's parallel to x plus 5y equals to 9. I don't know about you guys, but for me, it's usually simplest to rewrite this in terms of slope-intercept form. So I would take the 5y and subtract off x. So it's equal to negative x plus 9. And then you can divide by 5 to get y equals negative 1/5 x plus 9/5. From there, it should be pretty clear to see what the slope is. And to get a parallel slope, we need the same slope. So it'd be answer choice G. Okay, let's see what other kinds of questions we have here. Here's another geometry problem I found. It also doesn't look too difficult given that we just covered number 21 here. But we have a triangle where the measure of angle A is 58 degrees and AB is congruent to AC. The side AB is the same as side AC. Well, guys, that would make this a special type of triangle, right? They didn't label it here, but this is an isosceles triangle. Isosceles, which means those two angles are the same. To get those angle measures, we'd have to take 180 minus 58 degrees and divide it by 2, right? So 180 minus 58 is what, 122? Yeah, and since we have to split that evenly between these two angles, each of them would get 61 degrees. This has to be isosceles triangle. So that's going to be answer choice D. I think this is maybe almost too easy for you guys. We have to look at some harder questions. Okay. So I'm looking here. Okay, this one looks like a good one. That's why I like the ACT. Kind of haven't done these types of problems in a while, but they're interesting. Regardless of how the graph is oriented in the standard coordinate plane, no graph in one of the following categories has a vertical line of symmetry. Yeah, looks like we've got an answer already. It seems like it's going to be K. And if we did not know this immediately, we could do process of elimination. So, for example, line has a vertical line of symmetry right there. A square has a vertical line of symmetry right here. A pentagon can also have a vertical line of symmetry. If you think about like this. So we can rule out that. Parallelogram. Okay, so what is a parallelogram? That is probably the most difficult one to rule out. But it's just a parallelogram is a quadrilateral which the opposite sides are parallel and equal. So a rectangle is a type of parallelogram, right? We can draw a parallelogram that looks like this. It doesn't necessarily have to be slanted, although it can be. Rectangle is a type of parallelogram so that we could rule out as well. And by process of elimination, we're left with only a scalene triangle, which that means all three of the sides are different, right? If all the three of the sides are different, there's not really a clean way to cut it so that we have a vertical line of symmetry. Okay, let's look at our next question. Ooh. Okay. Maybe I'm skipping ahead. No. I'm gonna do this next one right here. That was kind of similar to one of the daily questions of the day, the SAT questions of the day that we've been doing, that a lot of people had trouble with. It was about solutions, and volumes of solutions, and percent solutions. So here we have a barrel containing 25 liters of a solvent mixture that's 40% solvent and 60% water. Lee will add pure solvent to the barrel without removing any of the mixture currently in the barrel, so that the new mixture will contain 50% solvent and 50% water. How many liters of pure solvent should Lee add to create this new mixture? We sh Okay, that's a quick answer. Um, One thing we can do is set up an equation. We could also kind of just like do this by intuition, knowing that if we have 25 liters and 40% of it is solvent, then 25 times 0.40 is going to be 2/5, which is 10 liters of solvent. So we have 10 liters of solvent. We have 15 liters of water. 15 liters of water. If we add 5 liters of pure solvent, it looks like we'll get to 15 liters of solvent and 15 liters of water, which would make it 50% solvent and 50% water. So yeah, it looks like G is the answer. We'd add 5 liters of solvent to get a 50-50 mix. If you didn't want to do it with the guessing and checking, you can kind of write an equation here as well. So like 0.4 S plus 0.6 W equals 25. We have 0.4 S plus whatever we add. Let's say we add X liters plus, oh sorry, that's not right. We want 0.5 of S plus X plus 0.5 W equals 25 plus X. But that looks like it's giving me two variables or three variables and two equations. But, you know, given that it's 25 liters of solvent, it's 40% solvent, we have those numbers, right? Like this, we know that S is equal to 10. We know that the water is equal to 15 liters. So we kind of just need to plug those numbers into that second equation. 0.5 of 10 plus X, and then 0.5 of 15 equals 25 plus X. It is a little bit lengthier to do it this way, so you get 5 plus 0.5x plus 7.5 equals 25 plus x. We can move the x's onto one side, and we can move the constants onto one side. And I can see that I might have made a little mathematical error here. Yes, indeed I did. Because these are not the right equations. It's not 0.4s and 0.6w. It's 0.4 of the total is equal to s. Right? That's actually how we're able to solve for these values. So something like 0.4 of the 25 is equal to s. 0.6 of 25 is equal to w. So, I mean, I wouldn't, because you can do it like this, I wouldn't really waste time trying to make the equation, because you can kind of tell just by solving these that the number of the liters of solvent is 10 liters, you have 15 liters of water. If you want to get 50-50, you just look at how much you need to add to get to 15. So it's actually quite simple. Let's look at our next problem. It's kind of like a multi-part problem, actually. Let's do the first one. Some very nice coordinate geometry for us. A quadratic function f and a triangle MPQ are graphed in the plane below. Points M, 2a, 5b, and p are on f. M and P are on F. Point Q is not on F. In terms of A and B, what is the area in square coordinate units of triangle MPQ? So we got to answer. Let's check that. So the area of MPQ is going to be 1/2 times base times height. I think everybody knows that formula. The base, the length of the base here, can be determined by the difference between point M and P. MP has a length of 6a minus 2a, right? We have the x coordinates. Then to get the height, to get this of height of the triangle, we just need to take the y coordinate, which is 5b, and then subtract it from 0. So the height is 5b. So to get the area, we just have to plug it in. Its area is 1/2 times 4a times 5b. That's going to be 10ab. I see we got a lot of conflicting answers for this one. So let's just check the answer key real quick and make sure we're right. So question number 48 should be G. There's more to this problem as well. There's 49 and 50. So I'm gonna paste them over here and we'll kind of work side by side. 40, and let me label this as well. So 49 also refers to this, and question 50 will also refer to this. It says point M remains fixed and point Q will move to the right along the x-axis. As Q continues to move to the right, which of the following statements describes what will happen to the slope of MQ? I mean, we can visualize this, right? If slope of MQ, well, if Q moves to a new position, let's say, I need a darker color, but it moves to a new position, let's say it moves here to Q prime. Then the new slope looks like it gets less steep. It's already a negative slope. So, and we can't really say that the slope will decrease or stay the same. It looks like it will increase. However, it can never be positive. It can never be positive because it can never get above point M. And I forgot to send the question, so there's 49. Yeah, it's going to be D. Question number 50 is the last one that's related to this set of triangles and parabola question. It's asking for one of the following is equivalent to f of 5a. Which one? F of 5a. So that's the function evaluated at x equal to 5a. That's going to be, if I label it on the graph, f of 5a. That's going to be right here, 5a. The function evaluated at 5a looks like 8b. That would be answer choice K. So really, there's no solving that needs to be done there. You just need to look at what your input is and look at the function and see what the output corresponding to that is. Okay. Let's do another little geometry, difficult ACT math problem. So I've got a question on the last one about G. Yeah, it wouldn't be option G for number 50 because it's asking for when we evaluate the function with the x coordinate equal to 5a, what kind of output are we getting? So it would not be G, that's the input, but the output would be K. Let's move to 56. So question number 56. It says one of the following graphs, the solution sets to the systems of inequalities below is shown shaded. Which one? So in one of these, we could convert this, like right away I see we have a line and a circle, and that's my clue that we can convert one of these equations into a circle. When we move the 3y squared over to both sides, add it to both sides, we can get something like 3x squared plus 3y squared is greater than 12. And we can further simplify that to get, if you divide everything by 3, x squared plus y squared is greater than 4. So that's a radius of 2. X squared plus y squared greater than 2 squared. That's the radius. For the other equation, we can convert that into slope-intercept form to make it easier for us to analyze. So, for example, we can subtract off the x, and we get 2y is less than or equal to negative x plus 6. And then we just divide by 2 to get y is less than or equal to negative, let's call it negative 1/2 x plus 3. So these are the two equations that we have. X squared plus y squared is greater than 2 squared. So that's non-inclusive. It's going to be a dashed line. And the next equation, y is less than or equal to negative 1/2 x plus 3. That's going to be inclusive, so it's going to be a solid line. And by process of elimination, we can even start eliminating things like g. We can start eliminating, actually that might be the only one based on that metric, but we also want the shaded region to be below this line, below or equal to. We also want the line to have a negative slope, so we could remove j, we could think my mic cut out. So we eliminated g, h, j. Last thing is it going to be f or k? Well, this circle is centered on the origin. It has a radius of 2. The line here at when x equals 0 is at y equals to 3. That means it's above the circle, and that only matches with answer choice K. F is close, but the radius is just too large and it intersects that line. I see some questions about what does F mean if you're talking about F as a function notation. It means that we can define a function that maps certain numbers to other numbers, like the function f here is the function which maps any of these x inputs to the corresponding y input. So something like when x is equal to 5a, that maps to a corresponding y output of 8b on this line. Yeah, that one is, all three of these questions refer to the same graph. Let's pick another question and see. Do you guys want me to restream so you can, is the stream not showing up? Okay, let's try that. I don't know why that is. I just quit and joined. Okay, maybe some of you other guys can try that as well. I just restreamed, and this is our question that we're going to be doing. we're dealing with a cosine function. A cosine function is shown, and one of the following equations represent the function. Well, yeah, this is geometry. This is more like trigonometry stuff, and it's one of the harder questions on the ACT. So, one thing I notice about this graph is it's centered across the y-axis. The amplitude is 3 because it oscillates between -3 and +3. So anything like f and g we could eliminate. Now for considering the period of the graph, it looks like it repeats itself every pi units. So from here to here, it's pi, a distance of pi. And after that, the graph repeats itself. So let's look at what we have here. Normally, cosine repeats itself every how many units? If we just graph it out, cosine of x is going to repeat every 2 pi. So let me write that. Normally, cosine of x repeats every 2 pi. That means it's periodic, or it has a period of 2 pi. Here, that is shortened. It's actually cut in half. So we probably want to eliminate h. That's divided by 3. Now between j and k, what do you guys think? I see 2 answers for k. K would be correct, because if we took something like j, that's saying that we can actually stretch this out by double. In fact, anything we put in here would get cut in half. So in order to get the same effect of cosine repeating every 2 pi, we'd actually have to plug in x is equal to 4 pi to get the same effect. Whereas here, when we plug in x equals to pi in x equals to pi, it's the same effect. It's the same effect as repeating every 2 pi. Or it's the same effect as cosine of x when x equals to 2 pi. So that's kind of just one way we can approach that. Or if you know exactly how those transformations function, you know that cosine of 2x is going to cut that period in half. Let's do, I like these harder questions. This one looks like it might be dealing with the law of cosines, which is a topic that I think comes up pretty frequently on the ACT. So we have a flying kite. Let me send it. Adjacent over hypotenuse, someone says, well, we can only use the SOHCAHTOA rules in a right triangle. This does not look like a right triangle to me, given that we have a 75-degree angle, 45-degree angle, and the last one would have to make it sum to 180, which would mean it's, I think, 60 degrees. So, law of cosine states, let's see, there's a couple different ways you can write the form of the law of cosines, but what I commonly see it written as is this side length c is equal to a squared, or square root of a squared plus b squared minus 2ab cosine of angle c. Cosine of angle c. It's actually pretty similar to the Pythagorean theorem. This part right here is the Pythagorean theorem. We just include some kind of correction because it's not exactly a right triangle. And that's where this cosine term comes in. So we want to figure out the length of the string, right? It tells us here the length. We want to figure out the length in feet of the string. To get the length of the string, we just set that as our side C. So let's solve that out. That is going to be an unknown. we have the other sides, or actually we don't have those sides. Um, this might actually just be easier for us to use law of sines. So let's label this. This is law of cosines. We don't actually have this other side right here, so we'd have to first solve for this one. In this case, I would use law of sines because we don't need that missing side, or actually we can solve for it with law of sines. So anybody know law of sines? It's going to be sine A over side length A is equal to sine B over side length B is equal to sine of angle C over side length C. So that means that, we have this side length. We also have the angle opposing it. By the way, these refer to the angles. Angle A is the angle opposing side length A. So if we can substitute in some numbers here, we'd get something like sine of 60 degrees over 240. That's the corresponding ratio for this pair of this side and angle pair. And then we'd have across the string, we have a 45-degree angle, so that's equal to sine of 45 divided by, let's just call it x, because we don't know it. So if we rearrange this, we just get x is equal to 240 times sine of 45 over sine of 60. And I would just plug it into the calculator at this point to get 240 sine 45 over sine 60. Make sure if you're doing it with degrees, you have your calculator in degrees, otherwise you get a very different answer. But I'm getting 195.96. 195.96. It's around 196. That's not an answer choice, which means that I got a decimal approximation of one of these answers. But if I evaluate these, 80 square root 6 is around 195.96. 60 square root 3 obviously is not that. It's around 103.92. So yeah, we're left with, for 59, we're left with answer choice B. Yeah, different formulas you can use, law of sines, law of cosines. Fortunately, we can do it with lines of law of sines here. Let's do a few more problems. Oh, this is, okay. This one might be our best one because this one is deceptively hard. It looks really easy, but many people get this one wrong. If a publisher charges $15 for the first copy of a book that's ordered and $12 for each additional copy, which of the following expressions represents the cost of Y books? So it's very misleading because usually we write our equations in y equals mx plus b form, and when x is 0, the y-intercept tells us that initial value. But this is talking about for the first copy of the book. First copy of the book is not when x is equal to 0. This is actually when x is equal to 1. So if we substitute in some values, we get y equals say y becomes 15, and we have m times 1 plus b. $12 for each additional copy, right? So 27, or 15 plus 12, let me write it like that. 15 plus 12 is equal to m times 2 plus b. If we want This is just one way to solve it, writing it as a system of equations. But we get 15 equals m plus b. And we get 27 equals 2m plus b. I can, for example, take the negative of this equation, and then I can add both of these together to get 12 equals m. What it's telling us here is the slope is 12, which we already knew that, right? We already knew the slope is 12, because for every additional copy it's 12. But the b value is what we're interested in. If 15 equals m plus b, then that means 15 is equal to 12 plus b. So that gives us b equal to 3. That's actually going to give us answer choice F, right? The slope is 12, and the intercept is 3. And that's because when x is equal to 1, we've already accounted for one copy of the book. That means the slope has been input there one time. That $12 has already been added once. So yeah, we start with an initial value of 3, and we get a plus 12 for every additional book we order. But it's very, very tricky question. That's why they put it at the end. Can try to summarize it in a different way. $15 for the first copy of a book. Well, that's not the y-intercept, because the y-intercept is when x is equal to 0, when we've got 0 copies of a book. So when we have 0 copies of a book, we pay $3. For the first copy of the book, we have to add on an additional $12. For the next copy of the book, we have to add on an additional $12, and it keeps increasing linearly. Yeah, we can look if we have some parabola problems. Actually, well, we did one that was kind of geometry and parabolas. I don't see any more parabola questions in this section, but there's definitely some on the SAT if you stick with me that I can find. So that would be in kind of our advanced math section where we deal with nonlinear functions. We might have actually done this one last time, so let me look at something we haven't done. This one is a really interesting one. This is one of the harder parabola problems you'll find on the SAT. It says we have a quadratic function where a and c are constants. The graph of y equals f of x is a parabola that opens up and has a vertex at h, k. If k is less than 0 and f of negative 9 equals f of 3, which of the following must be true? Let's see, I'm going to draw this out. So the vertex is at h, k, which would be somewhere below the x-axis, of course, since k is less than 0. We know f of negative 9 is equal to f of 3. So something like, the graph might look something like this. F of when x is equal to negative 9, the function is the same as if when x is equal to 3. The vertex is also at a negative y value. So which of the following must be true? C is less than or equal to 0. If we can find any counterexamples, then this would make it false. But let's kind of think about this. C is less than or less than 0. Well, C here is the y-intercept. From the way I drew it, yes, that is true, but I could have drawn the function in such a way where it's really, really steep. And if it's really, really steep, it could possibly have a C value that is positive at this point. At this point, C is greater than 0. Here, C is less than 0. So it's not necessarily true. That rules out A and C because we found a counterexample. And then A is less than or greater than or equal to 1. Well, we do want A to be positive for sure, but I could draw it such that A is really, really like a wide parabola. In this case, A could be between 0 and 1. In that case, that would rule out 2 as well. So the only thing we're left with is answer choice D. Neither 1 nor 2 must be true. We can find counterexamples for both of those. Okay. Let's do another one. This one, it combines quadratics with function transformations. Okay, we'll do I see someone submit. We have a ACT problem submissions. We'll do that as our last problem. And 2 more problems here for you guys. We've gone through a lot actually. The function g is defined by g of x equals f of x plus 5. We got an answer already. That's good. For what value of x does g of x reach its minimum? Well, a few ways we can do this. We can find where the minimum occurs for this function and then check f of x plus 5 because that's just going to be shifted over by some units. We could also plug in x plus 5 into this function, but I don't really feel like expanding all that out. If you were actually taking this on the digital SAT, honestly, I would just plot it in Desmos because it's going to be very easy for you to define f of x, and then you can very easily define f of x plus 5 as well, and you can find out that the minimum occurs at negative 13. I'll paste that in there right here. But let's say if you wanted to solve it out by hand, or you can do something like the minimum occurs when the min is at x equal to negative b over a for the original function. Yeah, Desmos allowed for the digital SAT. So negative b over a, that's negative 64 over 4. That's negative 16. Did I do that right? No. Sorry, negative b over 2a. So the minimum, the original minimum was at x equals negative 8. That's right there. If we want to find the transformed minimum, well, we just have to figure out which direction it's transforming in. So f of x plus 5 means that in order to get the same value, let's take, for example, we wanted to take f of 0. To get f of 0, we actually need to plug in x equals negative 5 because it's shifting everything, it's offsetting everything that we put by plus 5. So you see, that shift corresponds to a shift left 5 units. Left by 5 units. Shifts left 5. it's sometimes hard to remember how those shifts function. So that's why I do recommend you just plot it. But if you do remember, then you know that if the minimum was previously at x equals -8, then that just becomes x equals -13 after shifting left. And we got one more problem here. We're going to be doing this ACT problem. The sum of an infinite geometric series with the first term a and common ratio r less than 1 is given by a over 1 minus r. The sum of a given infinite geometric series is 200 and the common ratio is 0.15. So the sum is given by a over 1 minus r. The common ratio is r. We can start to substitute some terms in and see what we get. The sum is 200. A, we don't know the first term, and the common ratio is 0.15. So when we solve this, we get A is equal to 200 times 0.85. So A would be 160. The first term is 160. 170. Right. That's 200 times 0.85. So if the first term is 170, if the common ratio is 0.15, meaning when moving from term to term, we only retain 15% of the original value. Then 170 times 0.15 is going to be 25.5. So the second term is going to be 170 times 0.15, which is 22.5. Now you can see we're starting to approach that sum. If we add 170 plus 22.5, it's like 192.5. Keep on adding smaller and smaller terms. It makes sense. We can kind of check our answer here. I've not done this before, but geometric series was a common term in calculus. So I've done the concept. Anyways, that's all the space I have for questions today. Thank you guys for showing up. Don't forget to check out my YouTube channel, my Explore page. I have my newsletter on there. Great questions today. I'll be posting the recording on there. So definitely check it out. And I'll see you guys next week. All right.